Conductors, semiconductors, and insulators are materials that differ in their ability to conduct electricity, and their differences can be attributed to variations in their molecular structures. Let's discuss the molecular structures of each of these materials. Conductors. Conductors are materials that allow the easy flow of electric charge. In conductors, the valence electrons, outermost electrons, of atoms are loosely bound to the atomic nuclei. This loose binding enables the electrons to move freely throughout the material when a potential difference is applied. Conductors typically have metallic bonding, where the valence electrons are delocalized and can move easily between atoms. This delocalization is facilitated by the overlapping of atomic orbitals, creating a sea of electrons. Semiconductors. Semiconductors have properties that lie between conductors and insulators. In semiconductors, the valence electrons are more tightly bound compared to conductors but not as tightly bound as insulators. The conductivity of semiconductors can be increased by adding impurities through a process called doping. The most commonly used semiconductors are made from elements such as silicon, Si, and germanium, Ge. In their pure form, these semiconductors have a crystalline structure where each atom forms covalent bonds with neighboring atoms. The valence electrons in this structure are involved in covalent bonding and are not free to move. However, when doped with impurities, additional electrons or electron deficiencies are introduced, creating free charge carriers that can conduct electricity. Insulators. Insulators are materials that do not conduct electricity easily. In insulators, the valence electrons are strongly bound to the atomic nuclei, and there are very few free charge carriers available for conduction. Insulators have a tightly packed crystal lattice structure, where each atom is bonded covalently or ionically to its neighboring atoms. This tight bonding restricts the movement of electrons, resulting in negligible electrical conductivity. In summary, conductors have a delocalized electron cloud, semiconductors have a crystalline structure with controlled impurities to create free charge carriers, and insulators have tightly bound valence electrons and restricted electron movement. These differences in molecular structure give rise to the varying electrical conductivity observed in these materials.